Again, class, good morning. So, this is another situation in refrigeration system. So, this is the effect of superheating the suction vapor class. Okay? So, let us consider. So, previously, we already finished increasing the evaporating temperature, increasing the condensing temperature. So, by this time, superheating the suction vapor. Okay? So, let us now, class, consider this example. A simple saturated refrigerating cycle for R12 system operates on the evaporating temperature of -5 and a condensing temperature of 40 degrees Celsius. Okay? Show the effects of superheating the suction vapor from -5 to 15. Okay? So, take note, class, that the example are the same with the previous example. Okay? So, maybe only some of the values will be uh, renewed. Okay? So, if we take a look, class, the pressure enthalpy diagram, so you will notice that at 1, in superheating, the 1 prime is now located outside the saturation curve. Okay? Outside the saturation curve. That's why we call that as superheating. Okay? So, unlike the original is the condition, of course, at the state point 1 is saturated. So, but 1 prime is now superheated. Okay? So, take note, class, that the enthalpy or the entropy of 1 and 1 prime are different. Okay? So, because this line is, of course, different. Okay? This 1 to 2 and 1 prime to 2 prime are different. Okay? So, considering now, class, so again, it's 3 and it's 4 already known. So, the value at 40 is 238.5. So, for the saturated cycle, okay, 1, 2, 3, 4. The volume or the specific volume of the gas at -5 is 0.6496. And the enthalpy at 1 is 349.3. So, this is at -5. And then at 2, so at 961 is 1 is equals to S2. 372, okay? Or 373, okay? So, for the superheated cycle, so 1 prime, 2 prime, 3, 4, 1 prime, okay? Specific volume at 1 is at 261, so and 15 degrees, so that is 0.071 cubic meter per kilogram. It's 1 prime, of course, at 261, so 362, and at 2 prime, so for constant entropy process, so that is 387 kilojoules per kilogram. Okay, so let us now consider, class, the refrigerating effect. Okay, so for saturated cycle, the refrigerating effect is, okay, so the difference between the enthalpy at 1 and 2 originally, so that is 110.8. Okay, so these are already known, class. For superheated cycle, the difference is H1 prime minus H4. So that is equals to 123.5 kilojoules per kilogram. So take note, class, that in superheating the suction vapor, the refrigerating effect increases, class. So because the distance from the original condition to the final condition increases. Okay? From the original position. Okay? So, increase the refrigerating effect. Okay? Next is when superheating of suction vapor occurs in suction line. Okay? No useful cooling results. And the refrigerating effect is, okay, 110.8 kilojoules per kilogram. So, effect on mass flow rate per ton. Okay? So, same process, class. 211 kilojoules per minute. So, again, this 211 is obtained from 1 ton of refrigeration. Okay? 3.516 kilowatts multiplied by 60 minutes per second. So that is 210.6 something. And then divided by the change in enthalpy. So the value now again, class, is 1.904 already known. Okay. So in the previous example. So for superheated cycle, so with useful cooling, the mass flow rate is, okay, so 1.709 class. Okay. So 1.7. Take note that the value will decrease. Okay. So will decrease from 1.9 to 1.7 class. Okay. Next is the, okay, with useful cooling. So the mass flow rate is again 1.9, okay, 1.904 kilogram per minute per ton. So without useful cooling class. Next. Okay, so effect on compressor volume capacity. So for the saturated cycle, the volume flow rate is, okay, so originally, so that is 0.1904 times 0.60496. So that is 0.1237 cubic meter per minute per ton. So for superheated with useful cooling, okay, the volume flow rate is, okay, 1.709, okay, multiplied by 0.071. So the value is 0.1213 cubic meter per minute per ton. So but without useful cooling, so the value is 1.904 multiplied by 0.071 is only 0.1352 cubic meter per minute per ton. So look at now, class, the difference. Okay? So let us now consider the effect on COP. So for the saturated cycle, 4.88 is the value. Okay? For saturated cycle with useful cooling, class, 4.94. Okay, so which is greater as compared to the saturated cycle. Okay, so without useful cooling, the value is 4.43. Okay. So effect on work per ton of refrigeration. Okay. So for saturated cycle, so the work now is equals to M, H2 minus H1. So that is 1.904 multiplied by the change in enthalpy. So the value now is 43.22 kilojoules per minute per ton, or 0.720 kilowatt per ton. So for superheated cycle with useful cooling, okay, M prime H2 minus H1, so that is 1.709 multiplied by 387 minus 362, so that is 42.73 kilojoules per minute per ton, or 0.71 kilowatt per ton. So without useful cooling, so M prime H2 minus H1, so 1.904, 387 minus 362, value is 47.6 or 0.793 kilowatt per ton. Okay? So effect on condenser performance. Okay? So for QC, or the heat rejected. Okay, for saturated cycle, so the heat rejected is 1.904, the mass, multiplied by 372, and then 385.5. So the value now is 254.2 kilojoules per minute per ton, or 4.24 kilowatt per ton. So for superheated cycle with useful cooling, okay, so M prime H2 minus H3, okay, so the value is 253.8 or 4.23 kilowatt per ton. So without useful cooling, class, so that is M multiplied by H2 minus H1, so that is 1.904 multiplied by 387 minus 238.5, so the value is 282.7 kilojoules per minute per ton, or 4.71 kilowatt per ton. Okay? So here is now, class, the effect of superheating the suction vapor. So when superheating produces useful cooling, number 1, the refrigerating effect per unit mass increases. 2, the mass flow rate per ton decreases. 3, the volume flow rate per ton decreases. COP increases. and the work per ton decreases. Okay. When superheating occurs without useful cooling, so the refrigerating effect per unit mass remains the same, and then the mass flow rate per ton increases, the COP decreases, the work per ton increases, and the heat rejected at the condenser per ton increases. Okay? So, thank you very much, class. That's all about my presentation.